Fundamental counting principle, permutations and combinations. Like I said, it's part of you're going to be using the PRB key, the probability key on your calculator, because the biggest part about probability is how to count things. That's what we're going to do today. We are going to learn how to count. A little more complicated than you did when you were a little kid, but basically this is counting. How many ways something can happen? How many possibilities are there? That's what this is about. It's about how to count things. The first one we're dealing with are factorials, represented by an exclamation mark. It means multiplication. For example, 5 with an exclamation mark does not mean you say 5 with emphasis. It means that you have 5 times 4 times 3 times 2 times 1. And okay, combinations or permutations. You have a certain number of items. You want to know how many of each you're going to have. If you take, you have 26 people, and you want to know how many you're going to do. You're in your club, and you're going to pick the president, the vice president, and the secretary. How many ways can you have that grouping of 3 based upon how many people are in the room? Okay. You want to form a committee, the homecoming committee from that same group, 3 people. It's different. Okay. Different between a permutation and a combination, and this is the most important difference between the two. A permutation order matters. Which one gets picked first, which one gets picked second, which one gets picked third matters. So if you do something like president, vice president, and secretary, it matters whose name gets drawn out of the bag for each position because the duties are different. So that would be a permutation. Order matters. Combination, order doesn't matter. You have a committee of 3 people. You pull out 3 names. In theory, they all have equal duties, so it doesn't matter whether you're the first name out or the last name out. It doesn't matter. Order doesn't matter with combinations. Biggest difference between the two. Now, there are 2 formulas for permutations and combinations. N is the number of items we have to choose from. R is the number of items we are choosing. Okay. Now, there was one of the factorials I didn't talk about. 0 factorial. If you look at factorials, they're the number times number 1. Where does it end at? It ends at 1. Okay. Now, by definition, if you do 0 factorial on your calculator, 0 factorial is 1. It has to be, because when you get down here, if I am picking the number of items, this is the same number. Let's say I've got a bag of 10 letters in the bag, and I'm pulling them out and placing them down in order, but I'm pulling out all 10. There's only one way to do that. 10 minus 10 gives me 0. Okay, so I have to know I cannot divide by 0. We have to, by definition, make that 1. 0 factorial is 1. Okay, so if you have a 0 factorial, that's 1. By definition, we have to define that. But N is the number of items I'm choosing from. R is the number of items I am choosing. You can't choose more than you have. Let's say, like I said, I got a bag with 10 little chips on it. Each one has a different letter on it. I can't choose 11 items from those 10. What's the order I can put 11 of those 10 chips in? Sorry, I don't have 11 chips. I can't do that. So the number you're choosing has to be small, has to be equal to or smaller than the number you were choosing from. N is how many choices we have. Okay. These 2 buttons are also on your calculator under the probability. To do those, you type in your number, hit the probability, underline which one of those you want, hit the second number, hit enter, hit the second number, and hit equals, and it will give you the permutation and the combination. And we will do some of those together here in a minute. Okay.
If,
So
there a difference between C and C?
Yes, there is a huge difference between the two. Permutations, order matters. Combination, order does not matter. And if you look at the formula, R factorial, that's a big difference in the number of times. We're actually removing all repeated combinations. That's what we're doing. Okay. So, what I wanted to do on this one here is actually, on the first few, we'll do them together. Write out and simplify, then confirm it on your calculator. So what is 6 factorial? 6 times 5 times 4. Yeah. Times 4 times 3 times 2 times 1. Then you get 720. Okay. I do want you to write these out. Okay. I do want you to write these out because I want you to understand and ingrain how you do them. Okay. 8 factorial divided by 3 factorial. Now, if you're doing this by hand, it actually works out. It's not nearly as complicated as it looks. So I have 8 times 7 times 6 times 5 times 3 times 2 times 1 all over 3 times 2 times 1. But look what happens. A bunch of stuff cancels out. So I have 8 times 7 times 6 times 5. Nope, times 4. Thank you. My bad. Can't count this morning. 6,720. Yeah, you could do 8 factorial divided by 3 factorial, and your calculator will spit that out as well. Part of the reason I want to write these out is so you can get that ingrained in your head exactly what a factorial is. Okay. Next one, 12 factorial over 6 factorial divided by 3 factorial. So I have 12 times 11 times 10 times 8 times 7 times 6 factorial, right? Because it's 6, 2, 3, right? God, I'm just off this morning. And then I have 6 factorial times 3 times 2 times 1. Because after I get down here from 7, it's 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1. Those cancel. 3s and 2s, so I can reduce 3 and 2 goes into that 6, goes into here 2 times. I can actually reduce down what I'm doing. If I'm doing this by hand, which is the old-fashioned way, I can simplify it down. I can cancel stuff and make it a lot easier than it looks. But honestly, if I'm doing this one here, and part of this is sometimes your calculators will freak out on some of these bigger numbers. 12 factorial is a big number to work. It does work, but it gets pretty big. But you can type this in all at once. 12 factorial divided by 6 factorial divided by 3 factorial. Whatever's on the bottom, you divide by. Whatever's on the top, you multiply by. And you can type it all in at once, and you get your answer, which is 110,880. So like I said, let your calculator do the heavy lifting for you. Okay, you want to have your calculator do the heavy lifting for you. So 4 factorial times 3 factorial, 144. And then 10 factorial divided by 5 factorial. 30240. And then the last one, that could get really nasty if you were doing that by hand. 8 factorial divided by 4 factorial divided by 6 factorial. 846 84720. Yep. Whatever's on the bottom, you divide by. And whatever's on the top, you multiply. Even if there's multiple on the bottom, you always divide multiple. Unless you want to put parentheses around it, divide parentheses 4 times 4 factorial times 6 factorial in parentheses, but just do division by anything at the bottom, multiplication with anything on the top, and you're good. No. So she's asking, so I divide by both of these. So I can either divide by this, divide by that, or I could multiply them and divide by the whole thing. Do those. Okay, those are the numbers you should get for that. He said, let your calculator do the heavy lifting, realistically, but you do need to understand what factorial means. Okay, and it is, factorial is a way of counting. If I have 5 things, how many ways can I do them? What's the order I can do them in? Okay, 5 times 4 times 3 times 2 times 1. That's how that one works. So, okay, example problem 2. Write out and simplify and confirm on your calculator. These are permutations and combinations. You will not have to compute using the formula, but you will have to recognize the formula and get it right. These formulas will not be on the board during your test, but you will be asked a question to give me the formulas. You've got 2 formulas. Freaking memorize them. Take the time to learn and memorize them. You've got a week. Okay. So, permutations. The number of things I have divided by the number of things I have minus the number of things I'm choosing. Factorials. So this would be 5 factorial over 5 minus 3 factorial. Now, which reduces to 5 factorial divided by 2 factorial. You can do that. But use the permutation key on your calculators. So you type in 5. And then you hit the probability, make sure permutation is underlined, choose that.
Equal.
There you go. I hit the wrong one, sorry. Yeah, you have to hit enter on yours. After you hit the probability one, you have to hit enter to have it show on the screen, and then you hit the second number, and then you hit enter or equals. Yeah.
Did you get 6?
Not yet, because I hit the wrong 5p3, and I do think that's correct. Yeah, 60. So there are 60 ways. So I have 5 people. How many ways can I arrange 3 of them in the first 3 seats? We'll get to that. Which one's which? We'll get to that. We'll get to that in a little bit. Right now, we're just practicing using the formulas. Okay. So in the next one, same idea. Probability, permutation of 10 things, taking 7 at a time. So I have 10 factorial over 10 minus 7 factorial. And you get 604,800. And then 4p4, 24 ways. How many different ways can you arrange 24 items? Order matters. So how many you got 4-letter words? You got 4 letters. How many different ways? How many different ways can you arrange those 4 letters? There are 24 different ways you can do it. Okay, and if you look at the formula, 4 factorial over 4 minus 4 factorial. This is where 0 factorial comes into place, because if I get 4 minus 4, I get 0. If we counted that as 0, this wouldn't exist, but it does work. So that's why we have to define 0 factorial as 1. Now, a combination order doesn't matter. These numbers will not be the same. So this one is how many ways can I have five items pulling 3 at a time, or pulling 3 items 1 at a time. How many different orders can I get them? So you got a bag of 5 numbers, 1, 2, 3, 4, 5. And I reach in and I pull out 1 and I put it down. I reach in, pull out 1 and I put it down. I reach in and pull out 3, pull out the next one and put it down. And the order I pull them out makes a difference. That would be the permutation. This one here, I've got the same bag of 5 numbers in there. I reach out and pull out 3 and look at what I have in my hand. Doesn't matter which one I pick first. I have no idea which one went in my hand first because I reach in and pull out 3 at a time. Not pulling out 1 and laying it down, pulling out 2, laying it down, pulling out the third one and laying it down, and writing down the order. The combination is you reach in and grab 3, and what do I have in my hand? And then, whether 3, 2, and 1, doesn't matter which order they're in. 1, 2, 3, 2, 3, 1, 3, 2, 3, 1, 2, it doesn't matter because I have the 3 in my hand. I have no idea which one came first. That's a combination. And so this one, 5 factorial over 3 factorial times 5 minus 3 factorial. Yes?
So just to clarify, because I think I might, I don't know. So 5 would be like how many there are.
How many there are and how many we're choosing.
Okay.
First number is how many there are. Second number is how many we're choosing.
Same with
Yep.
the C1. Okay.
Yeah. It's 5 minus 3. And that should not be 1, this should be R. I don't know why I wrote 1. My bad. And you get 10. 10 ways you can do that. And if you look at those first 2 numbers, order matters, order doesn't matter. There's a big difference between ordering mattering and ordering not mattering. It's the same thing. I've got 5 things taking 3 at a time, 5 things taking 3 at a time. One of them, it matters the order I pick them. One of them, it doesn't. It's 6 times as many for just that one example. Okay. So this one here, 9 factorial over 4 factorial times 9 minus 4 factorial. And I get 126. And then the last one, this one's different. First one was 24, 4 choosing 4 at a time. This one will be, how many times can I reach into a bag of 5 items and grab all 5 items? There's only one way I can do that. There's only one way you can do that. 5 times. If we look at the formula, 5 factorial over 5 factorial, 5 minus 5 factorial. 5 minus 5 factorial, this is 1. So I get 5 factorial divided by 5 factorial. There's one way I can do that. If I'm pulling 5 items out of at a time out of a bag of 5 items, I can only reach in and grab all 5 all at once. There's only one way I can do that. Okay. Okay, I'll let you finish these ones on your own. Just type them in on your calculator. Let's get to the next example so we can get to what we're doing. Okay. I need to remove this first. I am just going to take this first one right off the line, because there are too many different things we start arguing about the possibilities for a license plate. Because this is a 6-digit license plate or it's a 7-digit license plate. When I was a kid, there were 6-digit license plates, and the first three were all letters, and the second 3 were all numbers, or the other way around. You had 3 numbers followed by 3 letters, and 3 letters followed by 3 numbers. You didn't get them intermixed. Then they started intermixing them, and then they made them 7 digits instead of 6 digits long. And now they have stupid little symbols you can get in there. You can put little hearts on there now, all kinds of other goofy crap like that, so it gets carried away. And then there are certain letters that you are not allowed to have on a license plate. You're not allowed to have an O. You're not allowed to have a Q. You're not allowed to have an I. What does an I look like? a 1. So you can have a number 1, but you can't have likes. They all be capitals. You can have a 0, but you can't have an O, or you can't have a Q. Because they look like zeros. Particularly the Q's got a little line on it, but when you're driving behind somebody, it's not always easy to pick that out in a hurry. So yeah, there's all, I looked it up, I think it was last year, like, oh my God, these rules are unreal. So let's just skip that first one because it could just take forever to get through. So, next one. 5-digit even numbers. So I have a 5-digit number. 1, 2, 3, 4, 5-digit even number. How many choices do I have for the first number, the first digit? So I'm writing out numbers. 30,248. How many choices do I have for that first number? Why only 9?
Because you can't have 2 numbers.
I can have 2 numbers in one place. I can't have what? 1 through 9. Because I can't have 0. Because if I start with 0, it's no longer a 5-digit number. Because if you put 0 in the front, the 0 doesn't count. We don't have a 0. You can only have 1 through 9 in the first one, so you have 9 choices. How many choices do I have for my second number?
1 through 9. Oh, you have a 0.
I can have a 0, so how many choices do I have for the second number? I can have 10. I can repeat. I can have 9,994. I can, because I have to end in an even number. But I can have the same number all the way across. I can have 44,444. There's nothing that says I can't do that. I do have restrictions. My first number cannot be 0 because if I have 0 for this first number, it's no longer a 5-digit number. It'll now be a 4-digit number. But I can have 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have to have 1 through 9. I can have 0 there as well. So I have 10 choices here. How many for the next one? 10. How many for the next one? 10. And how many for the last one? And think about this one very carefully before you answer. What is the condition I am trying to meet?
It's 0.
Right. It says an even number. So what do even numbers end in? 0, 2, 4, 6, or 8. I only have 5 choices for the last number. If it's anything other than those 5 numbers, it's no longer an even number. To be an even number, it has to end in 0, 2, 4, 6, or 8. So I have 5 choices there. This is the fundamental counting principle. How many choices for the first times how many choices for the second times how many choices for the third, fourth, and fifth. I multiply them all together. This one's not that bad. 9 times 5 is 45, followed by how many zeros? 3. So there are 45,000 5-digit even numbers. Okay. So the next one, 622 phone numbers. Okay, how can I do 622 phone numbers? So, or 622. 622 is an implication of an area code. 530-212-707 area codes. So 622 area code. How many phone numbers are there in that area code? Or it could be that's the prefix. Think about it. When I was a kid growing up, everybody had the same area code. It was 805. And then everybody in the neighborhood or in the city had the same, had like 4 choices for the first 3 numbers on their phone number. So it's 488 or 486, and there's a couple other possibilities. It's 48 something. Okay, and then how many do that? So let's say that this is, how many numbers do we have in the telephone, in the phone number? You have 7 numbers, right? So you have 622. And then 1, 2, 3, 4. How many phone numbers will I have for that? How many choices do I have for the first number that follows? How many numbers can be here? 10. 1 through 0. Or 0 through 9, I should say. How many for the next one? 10. Can you repeat? Yeah, you can repeat. My phone number growing up was 3 digits. There were only 3 numbers used in my 7-digit phone number. There were several repeats in there. It's actually a very easy phone number to remember. I remember to this day, and I haven't used it in 35 freaking years. So 10, and then I would have 10, and then I would have 10. How many choices for the first, times how many for the second, how many for the third, how many for the fourth, and you multiply it out. 10 times 10 times 10 times 10, or 1,000. 488-4866. Like I said, very easy phone number to remember.
I'm sorry, where's I'm straight up confused about what's going on.
Okay,
Wait.
so you have a phone number, right? How many digits are in your phone number? You've got 7, right?
Okay.
So a bunch of people have their first 3 digits are all the same, 622. Those are assigned. Well, some of the rules have changed with cell phones, but it's still pretty close to the same thing. Everybody has an area code that's based upon where you live. Your 622, the next 3 numbers, is also based upon where you live. Yeah, it is. It's based upon where you live. It used to be like I said, the rules are kind of a little fuzzy now with cell phones. But when everybody had a landline, you could tell where they lived based upon these first 3 numbers here. You could narrow it down. You could narrow it down to a city. Okay. Everybody in my city had essentially like 4 possibilities for those first 3 numbers, and then you add these ones on here.
So, well, okay, but why is it all? So.
Because how many numbers can be here?
I mean, it doesn't have to be even or odd.
No, it can be anything.
Is that why it's
Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, so that's why it's all 10s and then on the upper one.
Right. And this one, because I couldn't have a 0 here, and on this one here, I couldn't have an odd number here.
So are there a couple different possibilities for the very last one on the 5-digit even numbers?
Yeah, if it's odd, it's have 5 other odd ones, but it'd be the same for odd or even. Okay. So let's take a look at this one, because this one will probably actually explain a little bit better. Okay. You want to seat 6 people in the front row of a class of 30. So I got 30 students, and I want to fill in the front row. How many ways can I fill in the front row? Just randomly pulling names. So I've got 6. Okay. So I've got 1, 2, 3, 4, 5, 6 seats in the front row. And all I'm doing is just worried about the front row. I want to pick the 6 kids that are in here. I'm assigning seats. I want to pick the 6 kids here. How many people can I choose from? How many kids can I choose from to sit here in this first spot? 30. How many from this one here?
30.
No, I can't do 30 because I already got 1 here. How many do I have left? 29, 28, 27, 26, 25. 30 kids to choose from for the first seat, but 1 kid's gone. I don't have 30 kids to choose from the second one. We're not cloning that first kid to fill in the second seat. So I have 29 kids to choose from for that second spot. And then 2 are taken, so I have 28 left. 3 are gone, so I have 27 left. And then I have 26 left and 25 left. So, yeah, that's a big number, ain't it? One, two, three. 427,518,000. That's how many I can do. Now this is actually a permutation here, because order matters how I pick kids. So on the combinations, I'm not saying, okay, you first 6, just pick a seat in the front row. I'm saying you sit there, 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 you sit there. Okay, and that's how that works. Okay, same thing. Cross this one out. Okay, these are on you. Let's go to here. These are the ones that are a little got to wrap your head around. Choose a vice president, secretary, and treasurer for a club of 25. These ones are all combinations or permutations, essentially. That's what the idea between these are. And what you have to do is decide, does order matter or not? Does order matter or not? If I have 25 people, and I'm picking a president, a vice president, and a secretary and a treasurer, 4 positions, let's say I'm doing it randomly, putting everybody's name in a bag. Does it matter whose name comes first?
Yes.
Yeah.
Yes.
Yeah, because the president's duties are assumably different than the duties of the vice president, treasurer, and secretary, right?
Yeah.
So whoever gets chosen first, the lucky president gets chosen first. It does matter. It matters. Order matters. Who I pick second, vice president, their duties are different. Treasurer, secretary, each one of those has different duties, different things going on. It does matter. Maybe you're willing to be the treasurer, but you don't want to be the guy in charge. You don't want to be the first name out of the box. You don't want to be the first name out of the box, then order matters. So this one would be a permutation. We have 25 items, and we're picking 4 at a time. How many ways can I do that? 25 P4. 303,600 different ways I can do that. A lot of possibilities. It's not, oh, there's only about a dozen ways. No, there's a lot of ways to have that happen. Choose a committee of 4 members from a class of 20. Does order matter? No, presumably with a committee, everybody on the committee has equal power. They have equal say. That's the idea behind a committee. So it doesn't matter if you're the first name or the fourth name, you're doing the same thing everybody else in that group is doing. So order does not matter. That would be a combination. 20 choosing 4 at a time. And there are 4,845 ways to do that. Okay, the next one. Choose 3 Word of the Week winners from 75 entries. Does order matter?
Yes.
You have to win, but does it matter between those 3 winners? Is there a designation difference between the 3 winners?
No, sir.
No, as long as you're one of the 3, you get the same thing. So order doesn't matter on this one. So this would be 75, a combination of 3 at a time. Let's see if your calculator's doing this one. There's a couple of numbers on here. Yeah, 67,525 ways to do that. And then the next one. I have 50 people, and I'm picking a $100 prize winner and a $50 prize winner. Does order matter?
Yes.
The best fun it does is $50. $50 is a lot of money. $50 is a tank of gas. Maybe 2 if you have a really small car. Maybe. Okay. Yeah, $50 is a lot of money. So this would be a permutation because order matters. 50, picking 2 at a time, picking 2, permutation. And there are 2,450 ways. And the next one. Okay, you ever play cards, play poker? This is the basic base of every probability in poker. How many possible hands there are altogether. Okay. Dealing out a hand of 5 cards from a deck of 52. Does order matter when you're dealing the cards? Order doesn't matter. You get the 5 cards, you pick them all up at one time. So it doesn't matter which one you got first, which one you got last. So this would be a combination, right? 52 cards, choosing 5 at a time. And there are 2,598,960 different combinations. Now, when you're playing poker, different hands have different values. Okay, some are better than others. That is based upon the probability of getting what you're looking for. This is the basics. This is the entire total possibilities. Then you figure out how many ways you can do each different one, and it gives you the probability of, let's say, it's getting a pair or getting 2 pairs or something like that. That's how that works. This is the basics for everything. Okay, so that's how the hands when you're playing poker, the difference between the two, which one's worth more. Why is the royal flush the highest ranking one? Because it's the hardest one to get. There are only 4 royal flush possibilities in an entire deck of cards. Your odds of getting a royal flush are 4 out of this. Really small odds of just drawing a royal flush. Okay, and that's where they get it all from. Questions? Okay, the rest of it you can figure out on your own. I do have a homework sheet for you.